We discussed this slide earlier, but we're going to return to it now in a wee bit more detail. And it's basically uh, going over the discovery of the subatomic particles, i.e. particles which are smaller than an atom. Remember, up to that point, atoms were considered the smallest thing in the universe, but Rutherford showed that the atom itself could be made up of even smaller particles. Up to that point, it was thought that atoms were a bit like kind of billiard balls. They're just kind of solid, everything, all the matter, and it's spread out evenly throughout it. But this experiment showed that that wasn't the case. And what he did was he took the high energy particles that he had available to him, which was alpha particles. They were the kind of highest energy things that he could access. And he fired it at thin gold foil, so just a few atoms thick. And what he showed was the vast majority of alpha particles just passed straight through. A small amount, we're talking less than 1%, they pass close to the nucleus and they get deflected by small angles. So you'll see these coming out occasionally, deflected in those sorts of directions. But very occasionally we get one deflected backwards. Now, at the time, Rutherford said this was like firing a cannonball at a piece of tissue paper and it bouncing backwards. Because the alpha particles we knew were very high energy, and there was no obvious explanation at first about why these things could possibly bounce back. And Rutherford came up with the explanation then that the matter of an atom must be very concentrated at one point in the atom, and he called that the nucleus. And therefore, what makes up the rest of the atom? Well, we now know, he knew the nucleus would have to be positive as well to repel the positive alpha particles. And so the rest of the negative charge must be spread throughout the rest of the atom. And that now gives us the model of the nucleus with the protons in it. Neutrons came along later, and the electrons in orbit round about it. So you need to be able to explain Rutherford's data and how he used that to create that model of the atom.